Good afternoon, ma'am. Ma'am, good afternoon. Wait for 1 more minute, ma'am. We can introduce our today's session, ma'am. Okay. Okay, ma'am. Thank you.
Good evening, everyone. I heartily welcome all the participants for the 5 days online FDP on Business Analytics organized by Department of MBA. Welcome the resource person Dr. Shyamla K, Department of Commerce, Srimati Devi Kunavar Nanalal Bhatt Vaishnav College for Women. She has a 15 years of teaching experience as an assistant professor in UG Department of BCom CS and presently holding position of head in charge from the year of 2019 and the college administration coordinator for the academic year 2020 to 21 and the valuation camp member for the year 2020 to 21. And she has a research contribution in guiding for scholars from 2021 onwards and doctoral committee member in Bharat University 4 scholars and doctoral committee member in Wales University 12 scholars, doctoral committee member in SRM University 1 scholar, and she has an academic audit member in the Department of BCom Bank Management on 2023 at DG Vaishnav College, and she has an academic audit in the Department of BCom CS on 27/3/2023 at DG Vaishnav College. I heartily hand over the session to Dr. Shyamla ma'am. Welcome, ma'am. Ma'am, can you hear me?
Yes, thank you. Thank you for your good introduction.
Thank you, ma'am.
Yes, good afternoon, my dear present here. Today's topic is business analytics. What is business analytics? Business analytics is the process of using data, statistical methods, and predictive modeling to analyze business performance and make data-driven decisions. It helps organizations improve efficiency, optimize operations, and gain competitive advantage. A key component of business analytics. Descriptive analytics uses historical data to understand the past business performance, say for example, sales reports and customer trends like that. Descriptive analytics, can we understand the descriptive analytics? The past in the data-driven method, descriptive analytics is the process of analyzing historical data to understand what has happened in the past. It provides insights into the trends, patterns, and key performance indicators by summarizing raw data into meaningful information. Key features of descriptive analytics. Summarization of data. The first one is summarization of data. We talk about the summarization. Convert raw data into understandable reports, dashboards, and visualizations. Next one is historical analysis. Examines past business performance to identify trends and patterns. Next one is data aggregation. This explains combined data from multiple sources. Say, for example, sales, customer transactions, website visits for better insights. Last one is visualization. Uses charts, graphs, and tables to represent data effectively and efficiently. Examples of descriptive analytics. Sales report. Say, for example, monthly sales performances by the region wise or the product wise. We have to get the report. Website analytics, number of visitors, bounce rate, and session duration. Customer segmentation, categorizing customers based on purchase behavior. Financial statements, balance sheet, income statements, and cash flow reports. Common tools used for the descriptive analytics, Microsoft Excel, Tableau. Microsoft Excel, we all know about Microsoft Excel. Basic data analysis and visualization tools used for data analysis. Tableau and Power BI, interactive dashboards and reports. Google Analytics, web traffic analytics, SQL and databases. Querying the historical data. Importance of descriptive analytics. Help businesses understand past performance, identifies patterns and trends to guide decision making, lays the foundation for more advanced analytics. Say, for example, diagnostic, predictive, and perspective analysis. Descriptive analytics is the first step in data-driven decision making. While it does not predict the future, it provides valuable insights that help business improve operations and strategy. Diagnostic analysis examines data to determine why something happened. Example, why sales dropped in a specific region, or why the product, we can't sell in the product in the particular region. Diagnostic analysis, understand why it has happened. It also the process of examining historical data to determine the reasons behind past events. It goes beyond descriptive analysis, which tells what happened by the answer. We have to get some answer from the predictive or the descriptive answer. This helps businesses identify causes of success or failures and to take correlative actions. Key features of diagnostic analysis. Root cause analysis. Identify the underlying reasons for a particular outcome. For example, why sales deadline in a region? Data drill down. Breaks down data into detailed categories to uncover deeper insight. For example, analyzing customer demographic affecting the sales or not. Correlation analysis. Examining the relationship between variables to understand influencing factors. Say, for example, the impact of pricing on customer retention. Anomaly detection. Identify outliers or usual pattern that may detect or indicate some issues. Say, for example, sudden spikes in website traffic or fraud detection, something like that. Comparative analysis. Compares different time periods, regions, or business units to pinpoint variations. For example, comparing marketing campaign performances. Example of diagnostic analytics in the business. Sales decline investigation. If sales drop down or it is not good in a particular area, diagnostic analytics can analyze customer behavior, competitor actions, and economic conditions uh, of the particular area to find out why. Customer crunch analysis examples. We have to analyze their feedback, complaints, and engagement level, something like that. It examine why customers stop using a service by analyzing their feedbacks. Operational performance analysis identifies reasons for production delays by analyzing supply chain data and workforce efficiency. Marketing campaign effectiveness determine why one campaign performed better than another one. And the engagement rate of the customers on customers demographic and advertising channels. Common tools for diagnostic analysis: SQL and database analysis for data querying and trend analysis. Tableau and Power BI for visualizing correlations and drilling down into the data. Python and R for statistical and machine learning based diagnostics. Next one is Google Analytics. Google Analytics also we have to use for getting avoiding web traffic. Example of diagnostic analysis in the business. Sales deadline investigation. If sales dropped or fallen down in particular area, diagnostic analytics can analyze customers' behavior, competitors' action, and economic conditions to find out why it happened in that particular area. Important of diagnostic analytics helps business understand the reasons behind the success or failure, identify areas for improvement and corrective action, provides deeper insights for strategic decision making, support predictive analytics by recognizing influencing factors. In overall, diagnostic analytics bridges the gap between what happened, that is descriptive analytics, and what will happen, that is predictive analytics, by identifying key drivers of business and performance in the organization can optimize operations and improve decision makings. Predictive analytics predictive analysis uses statistical models that may forecast future trends and customer crunch. Predictive analysis and forecasting the future. Predictive analytics uses historical data, statistical algorithms, and machine learning techniques to forecast future trends and outcomes. It helps business make predictive decisions by identifying patterns and predictive future events. Next one is key features of predictive analytics. First one is data mining. Extract useful patterns and insights from large data sheet. Statistical modeling uses techniques like regression analysis, time series forecasting, and classification models. Machine learning algorithms employs AI techniques such as decision trees, neutral networks, and clustering for more accurate predictions. Risk assessment evaluate potential risks and opportunities by analyzing historical data. Scenario analysis. Simultaneously, it different from business conditions to estimate possible outcomes. Examples of predictive analytics in business. Customer trends prediction. Identify customers likely to stop using a service, allowing businesses to take preventive action. Sales forecasting estimates future sales based on past trends, seasonal patterns, and market conditions. Fraud detection uses machine learning models to stop unusual patterns in transactions and defect frauds. Healthcare predictions predictions that remind to take risks or disease outbreak based on medical history and external factors. Supply chain optimization. The last one is supply chain optimization. Forecasts and demand fluctuations to ensure optimal inventory levels. Common tools for predictive analytics. Python and R for building statistical and machine learning methods. SAS and SPSS, statistical analysis software for predictive modeling. Tableau and Power BI, data visualization tool for forecasting trends. Google Cloud AI and apps, machine learning software, a cloud-based AI platform for predictive analytics. Next slide is importance of predictive analytics. It helps businesses anticipate future trends and make data-driven decisions. Reduce risks by identifying potential problems before they occur. Improves efficiently and effectively by optimizing operations and resource allocations. Enhance customer experience by predicting need and behaviors. Predictive analytics allows businesses to shift from reactive to predictive decision making by leveraging historical data and AI. It combines, can gain a competitive edge and improve long-term strategic planning. Predictive analytics provide actionable recommendations based on data analysis. Say, for example, optimizing pricing strategies. Predictive analytics is the most advanced type of data analytics that goes beyond predicting future outcomes. It provides actionable recommendations on what to do next by using data algorithms, machine learning, and business rules. Key features of predictive analytics, optimization models, determine the best possible decisions based on constraints. Say, for example, maximizing profit while minimizing cost. AI and machine learning uses advanced algorithms to learn from data and suggest improvements. Simulation techniques runs different scenarios to evaluate possible outcomes before making decisions. Decision automation recommends or even automates business actions. Say, for example, dynamic pricing in e-commerce, risk management, assess risks and suggest way to mitigate them. Here some examples of predictive analytics in business. Healthcare treatment recommendations. AI-driven system suggests the best treatment plan based on a patient data. Future outcome. It provides actionable recommendations on what to do next by using data algorithm, machine learning, and business rules. Just a minute. Optimization models determine the best possible decisions to constrain maximum profit and the minimum cost. It is the rule for every business analytics. Is here common tools for predictive analytics. Improve decision making, help businesses make data driven decisions with confidence. It helps to automate complex decision process, reduces risks and optimize resource allocation, enhance efficiently and profitability by suggesting the best action. Predictive analytics is the final stage of analytics, allowing business to not only predict the future but also determine the best course of action. It transforms insights into direct business value, enabling companies to stay competitive and innovative. One. Importance of predictive analytics. Improve decision making. It helps to lead, make data and strategic decision planning. How business analytics improve the decision making? Business analytics improve decision making by providing data driven insights, reducing uncertainty, and enabling organizations to make informed choices instead of relying on institution or guesswork. Business use analytics to analyze past trends, predict future outcome, and optimize strategies. Next one is way to exhibit business analytics, enhance the decision making. Data driven insights analyze large volume of structured and unstructured data, helps businesses understand customer behavior, market trends, and financial performance. Real-time decision making provides instant reports and a dashboard for quick action, enables business to respond rapidly to changing market conditions. Risk management and mitigation, identify potential risks and suggest preventive measures. Help in fraud detection, financial risk assessment, and cyber security. Predictive and forecast future trends and suggest the best course of action. Help in optimizing supply chain, pricing, and marketing strategies. Operational efficiency, streamline business processes by identifying ineffectiveness, reduce costs and improve resource allocation. Competitive advantage, helps business to stay ahead of competitors by leveraging market intelligence, identifies emerging trends before they become mainstream. For examples, how we improve decision making. First one is retail, optimizing product pricing based on demand and competition. Finance, detecting fraud and managing investment risks. Healthcare, predicting patient readmission rates and improving treatments. Manufacturing, reducing downtime by predicting equipment failures. Business analytics empowers companies to make smarter, faster, and more effective decisions by leveraging data and organizing the data-driven, reduce risks, increase efficiently, and gain a competitive edge. Enhance efficiency, identify area for cost reduction and productivity improvement. Business analytics enhances efficiently by optimizing process, reducing waste, and improving productivity through data-driven insights. It helps organizations streamline operations and allocate resources effectively and automate decision making. Why business analytics improve efficiency? First one is process optimization. Healthcare, in the healthcare sector, predicting patient readmission rates and improving their treatment quality. Manufacturing sector, reducing downtime by predicting equipment failures. Automated decision making, use AI and machine learning to automate repredictive tasks, reduces human error and speeds by processing. Resource allocation, ensure optimal use of manpower, finances, and inventory, reduce waste and prevent overstocking or under usage. Real-time performance monitoring, dashboards and reports provide insights to the operation process, enables quick adjustment to improve productivity. Cost reduction identifies area where expenses can be cut without affecting the quality. Improve supply chain management efficiently, reducing logistic cost. Predictive maintenance prevent equipment failures by predicting maintenance needs, reduce downtime and increase operational efficiency. Examples of efficiency enhancement using analytics. Manufacturing sector, predictive maintenance reduces machine failure and downtime. And the retail sector, demand forecasting ensures the right inventory level, reducing the waste. Healthcare sector, AI-driven scheduling optimize patient appointment and reduces wait times. Finance, fraud detection algorithms prevent losses and improve security. Business analytics helps organizations operate more efficiently by automatic processes, optimizing resources allocation on reducing operational cost. This lead to higher productivity rate, better customer service, and increased profitability. Boost customer satisfaction. Analyze customer behavior to improve products and services. Business analytics enhances customer satisfaction by analyzing customer behavior, predicting needs, personalizing experiences, and improving service quality. By leveraging data insights, business can deliver better products, faster responses, and more engaging customer interactions. Why business analytics improves customer satisfaction? Personalized customer experiences use customer data to recommend relevant product and services. Enhance marketing combines with personalized offer and content. Faster response time. AI-powered chatbot and automated support improve response effectively. Predictive analytics help businesses anticipate customer issues and resolve them properly. Better product and service quality. Identify customer performances and feedback their trends to improve their offers. Reduces defects and optimize product design based on data insights. Customer service sentiment analysis uses the text analysis to understand customer emotions from review, social media, and surveys. Help businesses address negative feedback and enhance satisfaction. Improved customer support. Analyzes service data to identify common issues and improve resolutions. Predicts potential complaints and enables proactive engagement. Loyalty and retention strategies. Identifies at-risk customers and provides Personalized retention offers enhances royalty programs based on customer purchase behavior. Say, for example, customer satisfaction engagement using analytics. E-commerce sector, Amazon uses predictive analytics to recommend personalized products. Banking sector, AI-driven fraud detection ensures secure transactions, improving trust. Healthcare sector, predictive model reduce patient wait time and improve care quality. Telecom sector, customer crunch analysis helps to improve retain users with tailored offer. Business analytics helps companies to understand, anticipate, and fulfill customer needs, lead to higher satisfaction and loyalty. By leveraging data-driven strategies, business can enhance customer experiences, strengthen relationships, and improve long-term retention. Identify market trends. It helps the business stay competitive and understand the industry trends. Business analytics helps to identify market trends by analyzing a large volume of data from various sources such as customer behavior, industry report, and economic indicator. By recognizing patterns and shifts in customers' performances. Business analytics helps identify market trends. First point, data mining and pattern recognition. Uses AI and machine learning to detect emerging trends in customer performances. Analyze past market data to predict failure customer demands. Social media and sentiment analysis. Monitor customer conversations, reviews, and online decisions to guess public opinion. Identify trending topics and product interest in real time. Competitor analysis tracks competitor strategies, pricing, and customer engagement. It helps businesses to adjust their offers to maintain a competitive edge. Economic and industry insight. Analyze global and local economic indicators to predict market fluctuations to help businesses to prepare for changes in demand, price, and regulations. Predictive analytics for market demand. Uses statistical models to forecast demand for specific products or services. Help companies align inventory, marketing, and production strategies. Customer purchase behavior analysis. Examine transactions and data to identify shift in buying habits. Helps business to create targeted marketing campaigns and new product line. Example of market trend identification using analytics. Retail brand like some new brands use analytics to spot fashion trends and adjust the product line. Finance, investment firms to track economic trend and predictive stock market movements. Technology, companies like Apple analyze customer preferences to develop new gadgets. Food industry, restaurants track customer demand for healthier, organic, or plant-based food. Importance of identifying market trends, help businesses stay ahead of competitors, enable a predictive decision making instead of reactive strategy, improve product development and making strategies, increases profitability by aligning offers with customer demand. By leveraging business analytics, the companies can monitor market shifts, predictive future trend, and adopt the strategies to meet evolving the customer needs. This leads to better decision making, higher customer satisfaction, and sustainable growth. Tools and techniques used in business analytics, data visualization, Power BI, and Tableau. Data visualization is the graphical representation of data and information. It uses visual elements like chart, graph, map, and dashboards to help people understand patterns, trends, and insights from complex data set. Data visualization makes the easier to interpret the data and communicate to the user and the customers, allowing user to make informed the decision making quickly. Key benefits of data visualization are simplify complex data, convert large and complicated data set into visual formats, making them easier to compare. Help identify trends, outliers, and patterns that would be difficult to see in raw data. Improve decision making. It provides key insights at a glance, supporting quick and informed decisions. Reduce the time spent analyzing raw data by presenting it in an actionable way. Enhancing communication. It makes easier to communicate complex findings to stakeholders, even those without technical backgrounds. Visualization are effective in meetings, reports, and presentations. Enable real-time monitoring. Interactive dashboards display real-time data, allowing businesses to monitor performance as it happens. Facilities to quick response and changing conditions or issues. Increase engagement. Interactive visuals engage users and invite deeper exposure and the data-driven techniques. Make data exploration more dynamic and engaging, increasing data understanding. Types of data visualization: charts and graphs, bar chart and column chart, good for comparing the categories. A line graph used to track changes over time. Pie chart represent properties and the percentage of the whole. Dashboards interactive platforms that provide an overview of key performance indicator, allow user to drill down into specific metrics and analyze them in the detailed manner. Heat map, color and coded map that display the intensity of the data point. Say, for example, sales performance by the region or in the product based, used to identify patterns and some algorithm or the geographical area techniques. Scatter plot, used to show relationship between two continuous variables. It helps to identify correlations and trends. Infographics combines data visualizations, images and text to tell a story. Used in marketing or communications to convey complex idea visually. Common tools for data visualization: Tableau, a popular tool for interactive and real-time dashboard. Power BI, Microsoft Power BI, business analytics tools for data visualization and reporting. Google Data Studio, free tool for creating customizable reports and dashboards. Excel, widely used for simple chart, graph and pivot table. Quick View, a tool that combines data visualization and analytics for decision making. Examples of data visualization in action: retail sector, a company might be used heat map to visualize sales performances by region or the product wise. It helps them to understand where to focus the marketing team effectively. Healthcare, a hospital uses time series graph to track patient wait time over days or weeks, optimizing that lead to avoid the wait time. Finance, investment firms use line graph to track stock market trends and make better investment decisions. The manufacturing sector, dashboards to monitor production efficiency, downtime and defect rates in the real time. Data visualization tunes complex data into clear, actionable insights. It simplifies analysis, enhance decision making and improve communication, making essential for business seeking to make data-driven decisions. Statistical analysis or Python and SAS. Statistical analysis, the process of collecting, reviewing and interpreting data to uncover pattern relationships and trends. It uses mathematical techniques to make sense of numeral data and provide insights that can inform business decisions to improve processes and forecasting in the future outcomes. Key concept in statistical analysis: descriptive statistics, mean, that means average, the sum of all data point divided by the number of points. Median, the middle value in a sorted data set. Mode, the mode frequently occurring value in a data set. Standard deviation, measures how spread out the data is from the mean. Range, the difference between the highest and lowest value in the data set. Inferential statistics, hypothesis testing, used to determine if there is enough evidence to support particular particular claim about a population based on sample data. Confidence intervals, a range of values within which a population parameter is expected to lie with a certain level of confidence. Regression analysis, examine the relationship between variables and predict the value of a dependent variable based on one or more independent variable. Say, for example, sales prediction. The next one is correlation, measures the strength and direction of the relationship between two variables. Say, for example, sales and advertising spent. Probability theory involves determining the likelihood of an event occurring based on known data. It helps businesses to predict outcomes and assess risks. Say, for example, chance of product success, customer crunch. Next one is analysis of variance, ANOVA, used to compare means between two or more groups to see if they are significantly different from one another. It helps to identify factors that causes variability in data. Say, for example, comparing sales across different regions. Types of statistical analysis. First one is descriptive statistical analysis. Summarize and describe the characteristics of a data set such as mean, median, and variance. Used to provide a quick overview of data and highlight key metrics. Exploratory data analytics. It involves visually in specific the data through charts and graphs to identify patterns, outlier, and potential relationship between the variables. Predictive statistical analysis uses historical data to forecast future outcomes based on statistical models. Say, for example, regression analysis, time series analysis. Predictive statistical analysis. It provides recommendations on what actions should be taken based on the statistical findings. Say, for example, optimization algorithms, simulations. Examples of statistical analysis in business. First one is retail business, analyzing customer purchasing behavior to predict which product will be popular in future. Healthcare sector, analyzing patient data to determine the effectiveness of a treatment and predict recovery times. Finance, using regression analysis to access the relationship between market factors and stock prices. Marketing sector, performing A or B testing to compare the effectiveness of different marketing strategies. Common tools for statistical analysis: Excel, Before that, we have to discuss basic statistical functions such as mean, median, and standard deviation, or on Python for advanced programming languages for statistical modeling, data visualization, and machine learning. SPSS and SAS, statistical software used for data analysis in various industries. Minitab, a tool widely used for quality control and Six Sigma projects. Importance of statistical analysis using business. It provides a solid foundation for making decision making based on data rather than assumption. Helps to recover hidden patterns and relationship within the data. Support predictive modeling and future trend forecasting. Improve operational effectively and help reduce cost by identifying area for optimization. Statistical analysis is essential for making sense of data, identifying key insights, and making data-driven decisions, whether used to describe past trends, predict future outcomes, or optimize business strategies. It provides valuable information that leads to better decision making. Database management. What is database management? Database management refers to the process of efficiently sorting out and organizing and reviewing the data within a database system. It involves using software tools to create, maintain, and manage database, ensuring data integrity and to use the applications. Key component of database management. Database management system is a software that allowing user to create and manage the database. It acts as an intermediary between users and the database, ensuring that the data is sorted and retrieved effectively. Database design. The structure of a database including tables, fields, relationships, and contains a well designed scheme. Ensure that database is effective, scalable one. Normalization. The process of organizing data to reduce rebound and dependency, ensuring optimal data integrity and store the database. The next one is data storage and retrieval. Data storage. Data is stored in tables which contains of rows and columns, that is field records and fields. The organization of this data is crucial for faster retrieve and management. Data integrity. Ensure the accuracy of the data and consistency of the data. Transactions. Ensure that database operations are processed reliably and data remains consistent in some cases of failure and automation failure, and the data structure failure. Database maintenance. Protect data from unauthentic and unauthorized access or corruption. Security measures it take, and it include user authentication and authorization. Ensure only authorized persons or authorized users can access or modify specific data. Encryption. Sensitive data by converting into the unreadable format. Database maintenance, backup and recovery. Creating backup regularly to avoid data loss and ensure data can restored when it is needed. We have to use that data. Performance tuning, optimizing queries and indexing strategies to improve database speed and efficiency. Updates and patches, keeping the database management system software to up to date with the patches and security and performance improvement. Types of database. Relation database, no SQL database, object-oriented database, graph database, cloud database. We will see one by one. Relational database. Use tables to sort data and define relationship between them. They use SQL for data manipulation. We use Oracle and SQL for the database management system. No SQL databases. Designed for unstructured or semi-structured data, no SQL databases do not use a fixed schema. They are suitable for big data applications and real-time processing. Object-oriented database. Store data in the form of objects, similar to how data is represented in object-oriented programming languages. Say, for example, DB4, ObjectDB. Graph database, used to represent and store data in the form of graphs, where entitles they connected with the relationship edges. Cloud database, hosted on cloud platforms, providing scalability, flexibility, and remote access. Say, for example, Google Cloud, Amazon RDS, Microsoft SQL database. Real-world applications of data management. E-commerce, outline stores like Amazon or eBay. The database store their customer information or the customer data, and their transactions are recorded. Banking sector, banks used database to manage accounts, transactions, and customer information. Likewise, Healthcare sector, hospitals use the database to store patient records, medical history, appointments, and billing informations. Telecommunication, telecom companies use databases to manage customer subscriptions, call records, and service usage of the data. Effective database management ensure that data is stored, accessed, and managed efficiently while maintaining data security, integrity, and accessibility. It forms the backbone of many businesses operations, enabling the organizations to leverage data for decision making, customer management, and operational optimization. Machine learning and AI, artificial intelligence, are the two interrelated fields of computer science. Focus on creating systems that can perform tasks that typically require human intelligence, while AI refers to the broader concept of machines being able to carry out tasks intelligently. Machine learning is a specific subset of AI that focuses on enabling machines to learn from data and improve their performance over time. Artificial intelligence refers to ability of a machine or system to mimic intelligent human behaviors. AI systems are designated to solve problems, make decisions, and perform tasks that would typically require human intervention. These tasks can range from reasoning, planning, understanding natural languages, and visual prediction to decision making. Types of AI: narrow AI, that is weak AI, are designed to perform a specific tasks. Say for example, Alexa, Google Assistant, focuses on one problem and cannot perform tasks outside of that domain. General AI, strong AI, theoretical concept where machines could perform any intellectual tasks that human can do. This level of AI is still a goal for researchers and has not yet been achieved. Super intelligent AI, a level of AI that surprised human intelligence across all areas. It is superative and remain a long-term objective for AI researchers. Machine learning. Machine learning is a subset of AI that focuses on the idea that system can learn from the data, identify patterns, and make decisions with minimal human intervention. Instead of being explicitly programming for every task, a machine learning model uses data to learn from experiences and adjust its behavior accordingly. Key concept of machine learning. The model is trained on labeled the data with known outputs. The algorithm learns to map input to correct outputs, making predictions and unseen data. Say for examples, email spam detection, fraud detection, and medical diagnosis. The model is given data without label and must find pattern and relationship of the own data. Used for tasks like clustering and dimension reductions method. Say, for example, market-based analysis, customer segmentation, reinforcement learning. The system learned by interaction with its environment and receiving feedback in the form of rewards or passions. The system aims to maximize its cumulative reward over time. Say, for example, robotics, game playing. For example, AlphaGo. It is a robotic game. Semi-supervised learning, a hybrid approach where a small amount of labeled data is combined with a large amount of data. It is useful when labeling data is expensive or time consuming. Deep learning, a subset of machine learning that uses natural network with many layers of networks to learn from vast amount of data, particularly effective for image recognition, speech processing, and natural language understanding. Say, for example, self-driving cars, voice assistants, and image recognition system. Key algorithms in machine learning, linear regression, used for predicting a continuous value based on input features. Decision trees, a tree-like model that used for decision-making process. K-mean cluster, a method of unsupervised learning that groups of data into cluster-based similarities. Support machine learning system. It used to create, model, and classification the task. Neural networks, that model is used for human brain's structure and function. Real world applications of the database management system. When we talk about the real world application means again we have to talk about the natural language process, computer version, healthcare sector, finance sector, retail and marketing system, autonomous vehicles, gaming, like that. Now the time is 5:25. Any doubt and or clarifications? Can you please ask your doubt and clarifications? Any questions?
Participants, if you have any doubt, you can ask now. Participants, if you have any doubts. Shall we wind up, ma'am?
Yes, ma'am.
Okay. Thank you for the informative session, ma'am. And I like to thank all the participants to listening the session patiently. And feedback link is given in chat window. All the participants should fill the feedback link for day 4. Thank you all. Thank you, ma'am.
Thank you.
Thank you, ma'am. All the participants are asked to fill the feedback link and may leave. Thank you all. Thank you.